Hello, my name is Seyong. For this assignment, the task was to compare the LSTM and the transformer encoder on AG news classification. The two models and the dataset are given. My job was to design a fair comparison, run it across input ranks, and analyze the result. The given task is AG news classification. Each article goes into one of four balanced topics: world, sports, business, and sci-fi tech. The two models read a sentence in opposite way. The LSTM read word by word, left to right, while the transformer look at all words at once and relates them directly. So my focus is simple, not which model is bigger, but how much the design difference alone matter. To test only the design, I made the two models almost the same size. Just the basic. The LSTM read word in order, keeping information in a memory called the cell state, with gate that decide what to keep or drop. This fixes the old problem of forgetting the start of a long sentence. Our is bidirectional, so each word sees both sides. The transformer use self-attention. Every word look at every other word directly. So far apart word link right away. Since it has no sense of order, we add position information. Remember to row in the table. First, cost. It compares every word pair. So work goes with the square of the ranks, or n squared. Second is better at linking for apart word. This explains the 2.4 times speed gap and the accuracy pattern later. The gas, thanks to self-attention, the transformer should improve more as input get longer while the LSTM pressure past a certain range. In short, the longer the text, the more the transformer should have. To test it, I changed only the maximum range, 64 and 128 and 256, and fixed everything else so we see the effect of ranks by itself. The data split into 108K train and 120, sorry, 20,000 for checking during training and 70,000 and 600 tests. The test set is used only once at the end. The key to parent is avoiding cheatings. The word list is built from training data only. Using the test set word inflate the scores. On the right are the setting kept the same for both models. Most importantly, the same speed before each one means both start from the same point and see data in the same order. So any gap comes from the design, not road. Both models have two layers, turn each word into 128 numbers and use masked meaning polling, leaving out padding to make one sentence better before choosing a topic. The LSTM read both direction, giving a 256 wide output and about 2.58 million width. The transformer add position into info and for attention had about 2.32 millions. The size gap is only 11% matched on purpose. So the result comes from the design and not from size. First result at length 128. The LSTM get 0.9103 accuracy, the transformer 0.8987. The LSTM read by about 1.16 point, and it also higher on macro f1, which treat all four topic equal. To check the gap isn't wrong. I ran a McNamara test, which look only at case where the two disagree. The LTM alone was wrong on 207. The transformer alone on 295 with a p-value on the 0.001 less than a 1 in a thousand chance of being random. So the rate is real. I got this from saved predictions with no retraining. Test loss was also lower for the LSTM. One note, the transformer wasn't fully trained yet. The next slide showed that. This showed the transformer hadn't finished running. The left is loss, right is accuracy during training. The LSTM runs fast, 0.9 accuracy after one pass. The transformer rises slowly, and its loss is still failing at the third pass. So more training would help. Meanwhile, the LSTM has trained loss 0.169, but check the loss 0.51 by the third pass. An early sign of overflipping, where it memorized instead of running. So the LSTM is fast but overfit early. The transformer is slow but steadier on new data. Third, the main test of gas. So changing only the input length across the 64 and 128, 28 and 256. On the current line from the 100 to 28 to 256, the transformer goes up 0.6 point, while the LSTM drops 0.27. Exactly the direction we guessed, and at 205.6, the gap nearly disappeared. So the direction is confirmed, but the effect is small. 80 news articles are short, so most meaning fits in 128 words and 256 mostly add empty space. The strong claim the transformer beating the LSTM on wrong text need a longer document. On the right, at 256, the transformer is about 2.4 times slower. The O and scared. The costs showing up for real. The clear trade-off, the small occurrence gains isn't worth the cost. Fourth, where the model got wrong. The 475 bus got wrong as 207 only the LSTM. The two the only the LSTM, the 295 only the transformer. The shared mistakes are mostly business versus sci-fi tech mixed up. HP and IBM running stories are really sci-fi and tech, but with word like running and market both called them business, not a flow, just hard, since the two topics share many words. Each model has a habit. The transformer got Google IPO or IEEE standard, right ranking for part tech names, but strip when a strong word like oil market pulls it the wrong way. So how each modern work show up in its mistakes. The warm-up. The first LSTM is a strong, efficient baseline and its read is real. Second, the transformer read point is not size, but how much data and training it needs. It improved better with more, so it could catch up. Third, the ranks gas was right in direction, but small in effect, since the article are short. First, the transformer costs 2.4 times more on wrong input. Or for short text, the LSTM is particle crunch and speed. For long or complex text or with plenty of data, the transformer may do better. Thank you.